So, last time we had defined a logarithm and we talked about, well, there's four properties of logarithms. I omitted the change of base formula here because it's not relevant to this next set of examples we're going to run through. So we talked about the product property, quotient property, and power properties. So today we're going to talk about two types of problems. Those types are expand the logarithm and then condense or contract the logarithm. So for expanding, we're going to go, or the order in which we'd apply our properties is quotient, and then product, and then power. The goal of an expanding is we want to write or take a single logarithm and to try to write it in with as many logs as possible. So for the expanding, we're going to be looking at what's going on inside the logarithm. So for a product property, you're looking for multiplication inside the logarithm. For a quotient property, you're looking for the division going on inside the logarithm. And for a power property, you're looking for an exponent inside the logarithm. Condensing is the opposite idea. So we're going to take many logarithms and try to write them with as few logarithms as possible. To do that, we're typically going to go in the opposite order. So power, product, quotient. And since we're trying to condense or contract these logarithms, you're going to be looking at the right-hand side of the properties. So for the product property, you're going to be looking for addition, quotient property, subtraction, and power property, a coefficient. Okay with that? Now, this is just the typical order in which you'd apply these properties. There could be something where you're doing you do something clever and what you're doing is equivalent to the same order. There might be some reason to violate the order because there's like a set of parentheses that are implying, oh, this thing needs to happen before you do this part or something like that. But we'll look at some of those kind of situations when we do the examples. Okay. So we'll start with some expanding examples. All right, our first example is log base 3 of 4x. So which property do we look for first when we're expanding? Quotient is the first thing on our list. Now, if we look at this, is there a quotient property present? No. Okay. Next would be product. Is there a product property here? Yes. How many? Well, how many multiplication symbols are there? One, right? We just have, the multiplication between the 4 and the x. So there's one product property going on. Everybody happy there? Okay. Since we've applied one of the properties, we need to start back over again, looking at the two new logarithms that we've created. So we're going to start at quotient again. If you look at log base 3 of 4, and log base 3 of x, is there a quotient property in either of those? No. Is there a product property in either of those? No? Okay. Is there a power property in either of those? I think you missed something.
4.
Yeah. 4 is not prime, it's a composite number. So anytime you have a non-prime integer like that, there will either be a product or power property going on, or multiple, depending on if it's like a crummy number, like, I don't know, like 30 or something, which 2 times 3 times 5, you know. But here we can just do this with a single power property. Everybody's okay with that? So we do have to be a little bit careful there when we're expanding. If we have a constant in there, we have to make sure that if that constant isn't a prime, that we've, you know, gone ahead and split it up either using power or product properties, or maybe some of both, right? Everybody's cool with that? Okay. Again, kind of a nasty trick, but it's a lot less nasty of a trick when I've shown it as something that can happen that we have to be on the lookout for, right? Let's do another one. So here we have log of 3ab to the 5th. First property we look for is quotient. Do you see any? Nah, man. Next we look for is product. Do you see any of those? Yeah, how many? 2, right? Because we have 2 multiplications going on. So we can do both of them, both all in one step. Everybody's cool with that? Okay. Easy to see kind of what's going on there, right? Okay. Since we've now applied a property and have new logs, we've created these new logs, we need to start back over. So looking at log 3, log a, and log b to the 5th, any quotients? Okay. Any products? Okay. Any powers? How many power properties? Just one. With which log? Yeah, the last one, the log b to the 5th. Now, how come I didn't have to mess around with log of 3? 3 is prime. Very good. Everybody happy? Again, not so bad. Right, so let's say we have ln, or the natural log of square root x cubed minus 5 all over 2x. First property we look for is quotient. Do we see any quotient property? Yeah, man. So that just allows us to split. So it always must be, when you're using the quotient property, numerator minus denominator. Just to be clear on that, the order matters, since there's subtraction and the order of subtraction matters. Everybody's happy with that? Okay, we got 2 new logs, so we have to start back over. Looking at natural log of square root x cubed minus 5 and natural log of 2x, do we see any quotient properties? No. Product properties? Okay, how many product properties? 1, where at? With the 2x, all right? So we do that. How's that looking? Look good to you guys? Ah, good catch, Paul. Yeah, this was, Mr. Kulik was trying to trick you. Paul refused to be tricked. There is a mistake with what we've written. The mistake is the minus sign in front of the log 2x needs to apply to the entire log 2x. So really we should have minus log 2 and minus log x. Probably, I don't know, a third to a quarter of students will miss that every single time. This is me trying to warn you about this. Anytime where you see multiplication in the denominator of a fraction like we have here, that should be your cue to knowing that you're going to need to distribute that negative. So be on the lookout for that. I'm warning you. All right. Okay. So we haven't. We made some new logs. So let's start all over again. Looking at these 3 logs, quotient properties. Okay. Product properties. Okay. Power properties. Okay. Where's the power property at? The square root x cubed minus 5. Okay, so how do I apply the power property to that? Okay, radicals don't distribute, so I can't make it x to the 3 over 2. I can take the 1/2 out front, though, because the exponent of 1/2 is the same thing as the square root. So that I can do. Because the square root is over the entire thing, I can take that exponent to the front. Is everybody okay with that? Can I take the power of 3 out? No. That's good. Why not? Because it's subtraction. The exponent of 5 isn't applying to everything inside of the log. If this instead hypothetically was that, then we could pull the 3 out front. But if it was instead this, you cannot. Mia.
Just like hypothetically, if it was like x cubed minus like 125.
That's what this is.
Yeah, could you like?
You could factor using the difference of 2 cubes and then use the product property afterwards. Yes, you absolutely could do that. Everybody's cool? You probably don't remember the difference of 2 cubes factoring pattern, other than one exists. But that's good enough. I don't think it'll come up. But yes, hypothetically, that would be, you would want to do that in that case. Absolutely. I don't think Mr. Kulik would be so cruel as to include a difference of 2 cubes factoring pattern question in here without actually ever going back and reviewing that factoring pattern immediately beforehand. Right? That's what we're talking about for those of you that don't remember. Just as an aside, since we're talking about it, I'll write it down. I don't think you need it. I haven't done all the homeworks in years, but because I don't need to anymore. Like I can do them, but I don't think that'll come up. Okay. So let's talk about some condensing ones. Here, Mr. Kulik has the ability to be a little bit sneakier. Oh, and we'll do that later. All right, so remember that for condensing problems, the order in which we want to apply the properties is reversed. So instead of going quotient, product, power, we're going to go power, product, quotient. And then our Q's are reversed, right? Instead of looking for the product property, instead of looking for multiplication inside, we're looking for addition outside. For the quotient, subtraction outside. And for power, coefficients outside. Okay. So here, first property we look for in condensing is power properties. Great. How many power properties do you see? 2. Okay. And you see them on the second and third logs, right? Okay. So let's apply that. That all look good to you guys? No? What don't you like? So you want, okay, so what we've done here is still correct. What Jack's saying that he wants to do is also okay. That's still okay to do. You could make that a plus and then make this x to the negative 2. Either way of doing it is going to be fine. You'll get to the same result, but you can do it either way. That's okay. Everybody's okay? All right. Next up, we look for product property. Great. How many product properties do we see? How many addition symbols do you see? 1. Okay. And between which two logs is the product property occurring? The first two. Okay. And Jack, I'm going to write the negative exponent as a reciprocal there. Okay. Next I look for quotient properties. Do we see any of those? No. Good eye. Wait a minute. There's subtraction symbol staring right there. Why isn't there a quotient property? Yeah, the bases of the logs are different. Nothing more we can do. Oh, Mr. Kulik, that's a nasty trick. Well, I've shown it to you, so now you know to be on the lookout for it. And either of these two answers is acceptable. They're both correct. They're equally correct. I would give both of them full marks without any prejudice or bias one way or the other. Everybody cool? Okay. Let's do another. Okay, so 4 natural log A minus 3 natural log AB plus 2 natural log B. First thing we look for is power properties. How many power properties do you see? 3. Okay. Notice here on the second log, when I apply that power property, I have to apply the power to the entire logarithm. And I'll, as Jack had pointed out earlier, we can take the negative exponent also with us doing the product property if you like. I'll carry that through and show you that we'll get the same result either way. It's 6 of one, half dozen of the other. But either way of thinking about it is okay. And in some cases, it might be easier to think about it that way. All right. Next, we look for product properties. Great. How many product properties do you see? 1 is correct. Between which logarithms is the product property occurring? 2 and 3 is incorrect. It's occurring between 1 and 3. Why? Because the second one has the negative sign in front of it. So really we should be thinking about it as this, because I know that I can add and subtract things in any order, right? as long as I'm keeping the negative sign in front of the thing that's being subtracted. That's equivalent. Everybody agree? So when I apply my product property, I'm there. Now, if we did this, the same thing on Jack's, there's two product properties because there is no subtraction symbol going on. Everybody's cool with that? So there, we would just apply then our negative exponent. And then we can reduce our fraction and be done. On the left-hand side, we still need to deal with the quotient property. And then reduce our fraction, and we end up with the same thing. Right? The advantage of using the negative exponent was there was no confusion either in terms of where the product property was occurring, right? They're just all product properties. We'll deal with the negative exponent with our exponent property to get the fraction instead of dealing with the quotient property, right? Because again, most of our instincts was applying the product property incorrectly. Well, I shouldn't say most, a lot of us, a vocal lot of you, right? Which again, like that's a nasty trick, but that's why I'm showing it to you in advance so that I can't fool you with it again later as easily. Because I'm not trying to fool you. I'm trying to school you. It rhymes. I'm a poet and I didn't even know it. Right. Another example. Let's make that. I'm going to use 4 of these, I think. Okay. First thing I look for. Power props, okay? Now remember, 1/2 exponent is the same as a square root. I'm going to just go ahead and write the square root in there. Or if you want to do it the other way, as Jack suggested, we can do that. So far, so good. All right, let's look at the left side. We'll do that one all in a row instead of jumping back and forth between the two sides. What's up next? Product properties, right? How many product properties do you see? 1, what's it occurring between? The first and the third, right? Can't trick you again with that. That's good. However, I did trick you with the number of product properties because there's a second one here that you haven't done yet. Here's my hint to you. Remember back when we expanded, when we had to distribute that negative? What's the opposite of distributing? Factoring, can I factor a negative here? Yeah. Oh, Mr. Kulik. That is some sneaky stuff. Sneaky, sneaky, guys. Again, I'm showing you all my best tricks here so that I can't fool you again. Look good so far? Now the last step would be quotient. And we're done. Okay. The advantage here of going and doing this Jack's way is that right away we don't run into any confusion on the number of product properties. We catch them all right away. And then all we need to do is apply our properties for negative exponents. And we're done at the same thing. Either approach is fine. They're both correct. They're doing the same thing. You're arriving at the same spot. I'm cool with doing it either way. You guys happy? Again, is this too hard? Not very hard, right? Like nice, easy, medium, easium. That was a joke. The last thing I want to talk about here is I want to refer to this fourth property of logarithms, the change of base formula. Oh my goodness. See you later, dude.
It's so caught up in logarithms.
I know, right? Happens to me all the time. And we're just going to prove this theorem here just for grins. I think I asked you to do prove some of these other theorems in the homework set. So just another example of how to do this. So I'm going to start off by defining the left-hand side as some variable. I'm going to just use A, capital A. Peace out, dude. Okay. And I'm going to use my definition of a logarithm to rewrite that as an exponential equation. Everybody's cool with that? Now, remembering what I want to get to, the numerator of the right-hand side, I need to be log base c of a. So I'm going to just take log base c of both sides. So now I have the numerator for the right-hand side. If I look at my left-hand side, though, you notice there's something I can do with that. What can I do with this? Power property. Yeah, exactly right. So I can write that as a times, log base c of b is log base c of a. Then I'll just divide both sides by log base c of b. I have the right-hand side now set. And remember, what did we define as capital A? way back in the beginning. That was log base b of a. That was the right-hand side. So I'm done, those guys. What happened so fast? You know, it's just the way these proofs go sometimes. You blink and you're done. It's like, whoa. Again, Mr. Kulik knew exactly what to do. There's no, like, he didn't have to think real hard. It seemed like instantaneously knew how to do this. This is not trivial to do for the first time if you're trying to do it yourself without having done it before. Just FYI.
Do you have to like do that on a test?
I haven't written the test yet, so I would
Put it on.
I would probably decline to answer that at this point, but I'll let you know before the test if I would put it on there.
Okay.
Is that fair enough?
You could just commit now to not put it.
I could, but I'm not really willing to do that right now because I don't want you to all skip the homework and just be like, Mr. Kulik will do it for me, and then I'll just have it done. I don't have to worry about actually having to know how to do this.
That's fair.
Because I'd like you to try the homework, you know, even if it's,
We should
you
like,
know.
go up and do those questions on the board, and then if we
okay. So we'll think about that too. All right. The thing I forgot to do at the start was ask if anybody had questions from the homework. So I'm going to do that here at the end. This is going to be my stopping point anyways. So if you guys have questions from homework, I would be happy to knock some of those guys out for you. Dom?
It's from like the unit set.
Yeah. What you got, Holmes?
You do number 96.
96.
Or just like that section, I don't really understand.
Yeah. What it's asking you to do?
Yeah.
Sure. We can do 96. It's as good of an example as any of them. It says, evaluate the logarithm or logarithmic expression to the 100th using your calculator and the change of base formula. So 96 says log base 12 of 259. So using the change of base formula, which is this, the power of the change of base formula is I get to pick what C is. My suggestion to you would be to use C as either the common log or the natural log. I am partial to the natural log because it's one less letter to write. Yep. So I can say that, and then it's calculator time. So we have natural log 259 divided by natural log 12. So that's 2.24 when I round to the 100th. And dunzos.
Okay, thank you.
Yeah, those are pretty nice, huh?
Yeah.
Take about 30 seconds to finish those set. Maybe more if you want to write down using the change of base formula, but whatevs.
Okay.
Who else with questions from homework stuffs? Could be oldies, could be newies. I'll do whatever, man. All right, fair enough. I want to point out to you guys that this was the end of section 5.3. There's only 15.3. There's only 5 sections in this chapter. What haven't we done yet? Homework quiz. What might you want to expect for Monday? Homework quiz. Obviously, seniors are exempt from that.
Oh, you guys need to-
I am a C.
In heart.
Senior citizen.